Today we will learn charpy impact test on metal specimen. Aim of the experiment is to perform the charpy impact test on materials. Apparatus required: impact test machine, test specimen, vernier calipers and steel rule. Impact strength: the resistance of a material to fracture under sudden load. Materials: mild steel square test pieces. The figure shows you the impact testing machine and the charpy test specimen. Theory: an impact test signifies toughness of material, that is, ability of material to absorb energy during plastic deformation. The type of test specimen used for this test is a square cross-section. The specimen may have single, 2 or 3 notches. The testing machine should have the following specifications: the angle 0 between top face of grips and face holding the specimen vertical is equal to 90 degree. The angle of tip of hammer is equal to 75 degree plus minus 1 degree. The angle between normal to the specimen and underside face of the hammer at striking point is equal to 10 degree plus minus 1 degree. Speed of hammer at impact is equal to 3.99 meter per second. Striking energy is equal to 168 Newton meter or joules. Angle of drop of pendulum is equal to 90 degree. Effective weight of pendulum is equal to 21.79 kg. Minimum value of scale graduation is equal to 2 joules. Permissible total friction loss of corresponding energy is equal to 0.5%. Distance from the axis of rotation of distance between the base of specimen notch and the point of specimen hit by the hammer is equal to 22 mm plus minus 0.5 mm. The longitudinal axis of the test piece shall lie in plane of swing of the center of gravity of the hammer. The notch shall be positioned so that it is in the plane of hammer. The notch shall be positioned its plane of symmetry coincides with the top face of the grips. For setting the specimen, the notch impact strength I is calculated according to the following relation, where I is equal to impact strength in joules per meter square. Procedure: first, for conducting charpy test, a proper striker is to be fitted firmly to the bottom of the hammer with the help of the clamping piece. Second, the latching tack for charpy test is to be firmly fitted to the bearing housing at the side of the column. Third, the frictional loss of the machine can be determined by free fall test. Raise the hammer by hands and latch in, release the hammer by operating lever. The pointer will then indicate the energy loss due to friction. From this reading, confirm that the friction loss not exceeding 0.5% of the initial potential energy, otherwise frictional loss has to be added to the final reading. Fourth, the specimen for ISO test is firmly fitted in the specimen support with the help of clamping screw and Allen key. Care should be taken that the notch on the specimen should face to the pendulum striker. Fifth, after ascertaining that there is no person in the range of swinging pendulum, release the pendulum to smash the specimen. Sixth, carefully operate the pendulum brake when returning after one swing to stop the oscillations. Seventh, read a position of reading pointer on dial and note indicated value. 8. Remove the broken specimen by loosening the clamping screw. 9th, the notch impact strength depends largely on the shape of the specimen and the notch. The values determined with other specimens therefore may not be compared with each other. Precautions: first, measure the dimensions of the specimen carefully. Second, locate the specimen charpy test in such a way that the hammer strikes it at the middle. Third, note down readings carefully. Result: the impact strength of material by charpy test. Viva questions. First, what is resilience? How is it different from poor resilience and toughness? Second, the ability of the material to resist stress without failure is called. Third, the impact test is done to test dash of a material. Fourth, in charpy impact test, the specimen is kept as dash. Fifth, in charpy test specimen, the angle of V-notch section is. Applications: in forging industry, the charpy impact test can be used to determine the malleability and ductility of a material that is being forged. In plastic industry, the test is used for analyzing the breaking strength of a sample when it is subjected to high impact from a pendulum. This helps in ensuring that the material is best for an application where it is subjected to such impacts.